In this video, we are going to study how to charge a capacitor. When charging, we need a source, and we do that through load. R is 4.3 10 to the 5th power. The capacitor 10 micro. So, in this case, we have two things. Across R, the current will decay exponentially like so, and the voltage across R also will follow. And this is the behavior. Exponential decay. The dynamic around C is different. This is C. It's different. So we start from 0. When the circuit is open, there is no charge, and therefore no voltage. So we start from 0. And then, as time evolves, everything will build up and increase to a certain value. Alright, so these are almost the boundary conditions. So if we wait longer, when you close this switch here, when you wait longer, there will be no current in R, and so 0, and no voltage. And so there will be a lot of charge here. A lot of charge. And so a lot of voltage also. So the charge is maximum, the voltage is maximum, as you can see in this graph. And so at that point, also remember, if there is no current, no voltage. So the voltage across the EMF is exactly the voltage across C. That's the maximum value. So the maximum value of the voltage is 100 volt. So first question, what is the maximum current in the circuit? What happens early on when you close the switch, a lot of charge are rushing, and so there is a lot of current, and the current is I0 before even reaching the capacitor. It's just the voltage, 100, divided by R, which is 4.3, and I put 10 negative 5 here, upstairs, right away. So I have 200, almost 33 milliamps, microamps. And that's my answer. That's the current I0. Alright. Number 2. What is the maximum charge? The maximum charge happens here when we wait long enough. So there will be no current in R. The voltage is same, the source, 100, and C. And the maximum Q max or Q0, we call it Q0. It's not really at T equals 0. Fine, we can call it max. Much easier probably. Max at the end of the process. It's just C. At that point, the voltage is max, which is the voltage of the source, because that's the only voltage we have. So that's 10 micro, 10 negative 6. That is C. And the voltage is 100. So 10 and 1000, this is just 10 negative 3 coulomb, or 1 millicoulomb. 1 millicoulomb. So that is the maximum charge in the capacitor if we wait long enough. Question 3. Question 3. Now, what is the voltage across R after 1 second? Now you have to remember, across R there is exponential decay for the current and VR. So I'm going to use this equation here. So the VR, the voltage across R, when T is 1 second. V0, the maximum is 100, which is also across R early on, exponential minus 1 second over RC. I'm going to write second of. So 1 second over RC. What is RC? Well, we can find RC. So this is R is 4.3 10 5. This is R times C, the RC time, and C is 10 times 10 negative 6. As you can see, this is just 4.3 second. So this is the RC time, 4.3 seconds. All right. Now, so I'm going to put here 4.3, the RC time. Now, the rest is easy. Just put this in your calculator. And I find 79, almost 79 volt. You see, it is less than 100. The voltage has decreased. And if I wait longer, 2 seconds, 3 seconds, after all, it will vanish to zero. You see, so pay attention. Here, when you charge, the current and the voltage are decrease and decay exponentially. Number 4. Now this is similar to discharging. How long will it take for the capacitor to charge to 78%? Obviously, if I wait long enough, the capacitor will be completely charged 100%. But before that, how long I wait for the capacitor? Just 78%. So we have to use this equation, this one here, you see, QT. So when QT is equal to 78%. What's 78%? 78% means 0, 70. I think this is easy. I hope you answer this. 70% of Q0 or 0.78, same thing. This is equal to Q0, the second part of this equation here. Second part, this one. And so Q0 and exponential minus T over RC time. Okay, I have to fix this. So minus T over RC, like so. Alright, now you can see here I lose Q0 and Q0, and I'm going to rearrange this equation. So that is almost 0.78 equals 1 minus exponential minus T over RC. Remember, what we are looking for is for solving for this T here. Okay, and the argument of an exponential function. So we rearrange this equation, bring this term here, make it positive, and bring this term here, make it negative. So it's very easy steps. So I'm going to find, I'm going to find exponential minus T over RC is equal to 1 minus 0.78, and this is just 0.22. Now use the natural log on both sides, so minus T over RC is natural log of 0.22. So obviously T is just minus RC time and natural log of 0.22. The RC is here, so the time T is just 4.3. I have the negative sign here, and natural log of 0.22. Now, if you do the math, you are going to find almost 6.5 second. So that's my answer. Right? So this is the kind of questions you may expect. So you have to distinguish between what's happening across R. So here, what's happening here is different from here. You have to answer that. I hope this helps.